Good morning, students. Now we will discuss about the Newton-Raphson method or Newton method. This is also known as the unnamed problems. How to find the roots of the differential equations. Okay. Newton-Raphson method or Newton method is used to the numerical techniques to find the approximate roots of your real valued functions. Okay. It's like given the roots, based on the roots, how do you find the positive roots? Okay. This is the formula for Newton-Raphson method. This is also known as the another numerical method to solve the equations f of x equal to 0. This condition is f of x equal to 0. It is used to the geometrical calculus, the geometrical of a curve, using the tangent line to a curve in a differential calculus. Okay. Now discuss about your problem. Find the positive root of x power 4 minus x equal to 10. First, in the formula for Newton-Raphson method, then xn plus 1, the nth term, xn plus 1 equal to xn minus f of xn by m dash of xn. First one is given function for nth term divided by the derivatives of the function. Okay, f dash of xn. Now discuss this problem. In the formula. Problem, find the positive root of x power 4 minus x equal to 10. Correct 3 decimal places using Newton-Raphson method. Simply use the NR method. Okay. Given the function f of x. This is the f of x. F of x equal to x power 4 minus x equal to 10. Then bring to the 10 in the left hand side. This is the minus 10. Okay. Then x power 4 minus x. Given f of x equal to x power 4, x power 4 minus x equal to 10, this then bring to the left hand side, here minus 10. Here f of x equal to x power 4 minus x minus 10. Okay. Here first find the derivatives of the function. Here given f of x equal to x power 4 minus x minus 10. Now the derivative f dash of x. First to find f dash of x. Here f dash of x equal to 4x cube minus 4x cube minus 1. The differentiating with respect to x. Given x power 4. What is the differentiation? Then x power 4. Here d by dx of x power 4. Here d by dx of x power n. General n into x power n minus 1. Here n equal to 4. Here 4 into x power n minus 1 means 3. Here 4x cube. Here 4x cube minus x. Differentiate with respect to x minus 1. Okay. Now substitute. Here f dash of 1. Now substitute the values 1 minus 1 from 0, 0 minus 1, 1, 2, etc. to find the positive roots. Okay. Here f dash of 1 equal to, now substitute x equal to 1, f dash of 1 equal to 4 into 1 cube minus 1. Here f dash of 1 equal to 4 minus 1, 3. Here f dash of 1 equal to 3. Okay. And then now substitute the 1 first value and then substitute 2. In x, here f dash of 2 equal to 4 into 2 cube minus 1, f dash of 2 equal to, simplifying this 31. Here f dash of 1, find positive root, and then f dash of 2 is the 31. Okay. Now, here now substitute this f of given function f of x equal to x power 4 minus x minus 10. Substitute this values n equal to 1. Here f of substituting x equal to 1, 1 minus 1 minus 10, here minus 1, this is a negative root. And then f of 2, this f of 2 equal to 4, this is a positive root. Having the negative and the positive roots, this is minus 10 to 4. Having the roots, positive roots are between these two values, here 1 to 2. Okay. The negative and the positive. Give example, this is 0, here this is the negative root, this is the positive root. Already you know the one value is positive and negative. Between these roots having the values. Okay. Between having the roots between these values. Here 1 to 2. Here the roots lies between 1 and 2. Okay. You take the approximate value here f of x equal to. In this formula x1 equal to the general formula xn plus 1 equal to xn minus f of xn by f of xn. Now substituting n equal to 0, we get x1 equal to x0 minus f of x0 by f of x0. Get this x0 value is 2. Now substitute this formula f of x equal to this, that is equal to 1.871, this value. And then the x2. Now take n equal to 1, we get x2 minus f of x1 by f of f dash of x1. Already find the values of f dash of x1, f of x1 values. Now substituting here this 1.871 minus this value. Simplifying this x2 equal to 1.856. Okay, and then continue the same procedure to find x3. Now substitute this values in formula. Here x3 equal to 1.856. Okay. Then what is the values? This x2 value and x3 is the repeated. Okay, x3 values are repeated. So this approximate value is 1.856. Next to find x4, to get the same values 1.856. Okay. To stop here, approximate root is 1.856. We get the approximate positive roots. Already I told you that this formula used to find the approximate positive roots of a real valued function. Okay. So we get the approximate. Thank you.